So let's see what an index is. In simple words, index is nothing but a pointer to a specific row ID. Row ID is nothing but the row address, which is composed of object ID, data file ID, data block ID, and the position in the block. In other words, an index can also exactly tell you where your desired blocks are sitting rather than scanning the entire blocks. The technical definition of index states that an index is a schema object that contains an entry for each value that appears in the indexed column of the table or cluster and provides direct fast access to the rows. This means that whichever columns or combination of columns in a table are indexed, the entry for such combination of column values will be recorded so that it can be directly accessed. The default index which Oracle creates is the B tree index or the balance tree index, so that it always has the same cost to find the bottom of the tree no matter what values is retrieved. So we'll talk about the B tree indexes in the forthcoming slides, where this concept will be much clearer. Indexes are mostly used in the where part of the clause. This means that indexes are mostly applicable to columns of the where part of the clause because such columns restrict the number of rows coming as output. It is also applicable to the select part of the clause, but in such cases, the columns or the combination of columns in the select part of the clause will be retrieved as a whole. In other words, all the table rows will be selected for the mentioned column values. Also, the most notable feature of index is that if you're trying to retrieve more than 15% of your table rows, then index will perform slower than a full table scan. For example, a table is having 100 rows, and if you're trying to retrieve more than 15 rows from the table, then in such cases, indexes will perform slower as compared to a full table scan. So if you're trying to retrieve more than 15% or more than 20% of your table rows, going with the full table scan is the best option. But full table scan comes with lot of CPU resource consumption, but the time wise it will be faster than the index when you're trying to retrieve more than 15% or 20% of your table rows. If time is not a constraint but the resource is a constraint, then you can still go with the index scan if you're trying to retrieve more than 15% of the rows as compared to the full table scan. The query will definitely take a little bit extra time as compared to full table scan, but the resource consumption wise it will be very less. Now let's see what is the actual purpose of an index. Suppose I fire a query, say select star from employees, where employee ID is equal to 248, and there is no index created on employee ID. Since Oracle doesn't know where employee ID 248 is sitting, it has to scan all the rows, and then only employee ID is equal to 248 will be selected and the rest will be discarded. This is obviously going to take a lot of time and CPU resources, as the entire table rows has to be scanned. Now suppose we have an index created on the employee ID column of the employees table, and since now the Oracle knows where exactly employee ID 248 is located, it will directly go to that block, fetch the row and come out, thus avoiding a full table scan. Hence, the sole purpose of the index is to avoid a full table scan and to scan only the desired row.